Jean is a young sugar beet producer, passionate about his work and always looking for new solutions to grow a better crop. One of his main concerns is weeds, because sugar beet is very sensitive to the competition of weeds. Jean knows that mechanical weeding is an efficient way of pulling unwelcome plants while reducing herbicide input. It also serves to control the attractiveness of weeds' flora on pollinators. When the weather is dry, with no rain expected, finely tuned machines allow for mechanical intervention as soon as the 2 to 4 leaf stage. Jean has also learned from studies carried out by the Applied Agricultural Research Organization for Sugar Beet that mechanical weeding processes have now become cheaper and not much more expensive than chemical only. The cost is estimated to be about 200 euros per hectare. Savings on herbicides will make up for machinery costs. Jean starts thinking about the best mechanical weeding strategies available. To achieve a significant reduction of the treatment frequency index, one must use what is called precision mechanical weeding in row and between rows. Several equipments are available. First of all, the rotary cultivator, whose finger weeders remove the weeds off the row. When used at the end of the weeding process, instead of a last chemical spraying, it will reduce TFI by 20 to 25%. One can also use the tine harrow to weed out on the rows and in between. Every single one of its tines relies on its own spring, which can be adjusted according to the condition of the soil and the stage of crop growth. Last but not least, there is the rotative weeder, made up of spring-loaded arms that carry star-shaped wheels. These are useful to remove weeds in row and in between. To further reduce herbicide input, one can use a row-specific band spraying boom, which allows application of chemicals only among the rows, and thus 33 to 50% of the field will be treated. This method is complemented by hoeing the inter-row several times. Jean understands the value there is to mixing different techniques. He is also aware of the need to reduce crop losses. So what is the best way to proceed? Well, Jean, to avoid crop losses, one should use a guidance system that can adjust the weeding implements with the necessary degree of precision. One can use a mechanical system where guide wheels follow deep furrows created at seeding. It is the simplest and least expensive tool available. It is also possible to resort to a system using cameras and softwares to process real-time images. A camera mounted on a cultivator films the beet rows and serves to direct the position of the cultivator relative to the rows. Finally, there is also GPS guidance systems. As soon as the seeds are sown, the GPS records the alignment of rows so as to guide the tractor along. The overhead for acquiring such technology may be steep, though the cost could be amortized through a range of implementations. Now that Jean knows about all the different possibilities available to him today, he wonders about what the future holds. Well, Jean, one can imagine robots being used for weeding control purposes. Several prototypes are already being tested. Those robots are equipped with artificial intelligence, real-time kinematic positioning technology, and embedded cameras. They should be able to work longer days and eventually reduce herbicide input. Robots would be able to relieve farm workers of the most exacting and repetitive chores, thus allowing them to save time. Some aspects still need further improvement, such as the autonomy of the robots, their ability to spot weeds at an early stage of development or to separate overlapping crop. A robot's output today is not yet competitive compared to a tractor, though a team of several robots working together could make up for the difference. Safety is another area of improvement.